Good afternoon, everyone.
Hello, good afternoon.
Yeah, thanks. So, this session, it's a machine learning. So, till now, all these sessions I have seen, and what we have learned, all the applications and how they are using it, and uh, what all the ways they have already there, and what all the pre-trained models are, how you can get a model from somewhere and you can use it in your project. And so these are all the ways we have seen the AI and ML so far we have seen. So what we will discuss or what we are going to see today is like, so from how are we going to uh, generate a model, how are you going to create a model from your own from the scratch, and what are the models are available, and for what purpose, what type of model you are going to use, and why you want use this particular model for this particular this specific use case. So these are all the things today we will just look it out, and we'll take one or two use case and we'll see how it is actually working, and what is the max behind it, and what are the and how it is going to give us the better result, and with the result what are we going to do that, and why we need actually machine learning or predictive modeling, and why AI, and from where it is AI, what is machine learning and what is AI, what is the difference, what is deep learning. So all these things we will just see. Yeah, okay. So we're able to, hope everyone can see my screen, right? Yeah, okay. So first, so what is actually a machine learning? So machine learning, the name itself, it's suggesting it's a machine. A machine is going to learn by itself. We are not going to program the machine every time. So what we do, programmers, so we have an input, we will get some input, and we have a desired result output. So we are going to code for that, and we are going to get the output from it. So what machine learning will do? Machine learning will try to learn by itself without code once again. Every time I want to code this for a specific requirement change, for a specific requirement change, we are not going to code every time. So it will learn by itself, and it will start uh, enhancing by itself. So that is what the term called as machine learning. So if we look at the type of machine learning, so we can categorize into 3 to 4, 5 many types. So I'm just trying to group it around some 4 category. So first one is of supervised learning, and second one is unsupervised learning, and third one is reinforcement learning, and fourth one is deep learning. So what is supervised learning? So I will explain. I will go to, depth into supervised, unsupervised, and all. So first, the categories, if you look, so supervised learning, it is like we are supervising the model. So like we will be there, and the model will get trained on, the model will get be supervised everywhere. Like we have a particular set of data to it, so that the model will learn by the data. So we know the output. So based on that, the model, whether the model giving the result is correct or not. So we are supervising it. So that's what the name, it's a supervised learning. So if you see the classifications and regression are the types. So what is regression, classification, will go a little bit next slide from the coming slides. And if you take a regression, so there are many type of models are there: linear regression, support vector regression, decision trees, random forest, XGBoost. So these are all the different types of models where they will use it in the regression. And if it's a classification, so they will go for a logistic, support vector classification, and decision trees, random forest, KNN, naive Bayes, XGBoost. So these are all the supervised learning models. And if it is unsupervised learning, it is clustering and association rule mining. So if it is a clustering, what is clustering? So it is like unsupervised. The name itself, it is saying it is unsupervised. So you don't know what exactly, so you don't know the output. The data won't be with proper output. So we are going to classify the data. We are going to classify the data on the part of labeling it, like this particular set of category belongs to this particular set of category belongs to this particular set of category. So we are going to clustering. So that is what it's unsupervised learning. And the major one, it is association rule mining. So this and all, we call it as a market basket analysis. So basically what this will do, if you see in Amazon and all, there is like people who bought this, they bought this. So plus that recommendation. So based on this association rule mining, so they will use this technique called market basket analysis. So this is what it is. And reinforcement learning. So the reinforcement learning. So what I told, supervised and unsupervised, reinforcement learning is one step ahead of that. So this is where it will learn by itself. So what it will do, first time it will try to learn the data, and it will try to predict the data, and it will get an error. So it will again back propagate. It will take a feedback of it. So okay, I will take a feedback. So I will again train, and I will do it, and I will try to correct the errors. So this is what artificial neural networks. So from here, AI is going to come. So then next one is deep learning. So in the artificial neural networks, so there will be like this input, output. So in the middle, there will be hidden layers. So we call it as a hidden layers. So so basically we will take one or two hidden layers for artificial neural networks. But when you go for a deep learning, the hidden layers will be more, because why we are separating artificial neural deep learning and reinforcement learning. So deep learning is like your network is very high, like the number of hidden layers will be very large. To process that, our normal machine is very not capable to process those. So we'll take many like TPU, TensorFlow processing units. So we will go for that. So to go with the deep learning and all, we need a model machines with heavy capacity. So to just put it in a way, like if you go for a deep learning, the number of hidden layers will be very high. So this is just an overview. So these are all the models like supervised, unsupervised, reinforcement, and deep learning. So these are all the categories of that. So just will deep enter into what is regression. So from here, everything is getting started. So as I told earlier, so what is supervised learning? Supervised learning, which is a predictive modeling technique where the model is trained on the labeled data set. So I will explain what is labeled data set. Okay, so you have an output. Okay, so I will just tell you the sample. Okay, so what is labeled data set? What is unlabeled? So take this is a use case. Okay, so I'm just showing one small data set, which is a very small data set to understand this algorithms. So just 13 records. So first, what it is showing, it's a profit in crores and research and development in lakhs.
Pandi,
Oh yes.
we are seeing your slides. Are you showing something different?
Oh, 1 second. 1 second. I'm again sharing. Okay, now you're able to see my Excel, right? Yeah, thanks. Thanks for that. Thanks. So what I'm showing, so this is a data set. Okay, so first one, what I'm profit in crores and research and development in lakhs. So this is a think that this is a data set of an organization. The organization invested research and development. Okay, the organization invested some lakhs in research and development. So they are getting profit of 12 crores. So for an example, they invested 45 lakhs in the research and development, and they got a profit of around 12 crores. Okay, so if they had invested 28 lakhs in research and development, and they had a profit of 8 crores. So this is what their past data. So that organization has gone for these years, and they had a data of that, and they are just presenting like, I have invested in research and development for this many lakhs, and I got earned in profit in this many crores. So this is what I'm talking. It's a labeled data set. So I have a perfect label for the data. So if I take the numbers 45, 28, 90, so what it is? So research and development, it is 45 lakhs. So there is a particular label to it. So this is what labeled data. You are able to see my slide now, right? Here.
Yes.
Yeah. Okay. So sorry. So that is called as labeled data set. So we are going to identify the pattern from that. So like, how are we going to identify pattern? That is where the models come from. So patterns are like, so from that data, what I'm going to achieve. So that is what it's a pattern. We call it as a pattern. So with that data, what I'm going to achieve. So that is what we call it as supervised learning. Okay. So first, I told there are two things. One is regression and the classification. So first I will enter into regression. Okay. So regression is like, it investigates the relationship between the dependent and the independent variable. So these words are very important. So dependent and independent. So what is dependent and what is independent? So if you look at the data, so if you look at the data, so what I'm talking profit in crores is a dependent variable. So the research and development in lakhs, which is an independent variable. Why? Because this profit is dependent on research and development, right? So like research and development, there are many more factors contributing to it. Like there are many independent variables contributing to it. So I'm just taking only one independent variable to showcase this. So this is one independent variable and profit is a dependent variable. So after understanding what is dependent and independent variable, we'll go into the old year max, like simple. So what it will do is it will show the dependent variable changes in the y-axis, and changes in dependent variable will be on y-axis and the independent variable will be on the x-axis. It's like if you look at this, it is just a data set, right? So if you look at it, these are all data. So if we try to plot the data in the Cartesian plane, like what I'm trying to explain. So you're able to see this, right? So if I have some data set, so I can able to present it in the graph, right? So the Cartesian plane, what I'm talking, it's a graph. So this is x-axis. X-axis all your independent variable and y-axis all your dependent variable. Okay. So first I have this data point. For an example, 45 and 12. So if I want to 45, if I want to plot this, so x is 45 somewhere around here and y is 12. So I somewhere around. So think that this is the data point. This is red color here I am showing now. So this is a data. So like that we are trying to plot all the data records. So whatever data we have, we are trying to plot it as a plot it in the graph. So we will get a graph like this. Correct? No? So these are all the graphs. So here, what are we trying to find? So we are trying to find a one proper best fit line, one proper line. Okay. So that line, which will help us to get the next set of, which will help us to predict the next set of results. So here, what I'm telling, if this dots here, I'm this green dot is there, right? So this green color line and this violet dots. So these are all the dots I am, my model is going to predict. Okay. So this is actual data points, what is from the data. So if I do a model, that model will give me the say, the model will predict instead of this point, it is going to give me this value. Instead of this value, it is going to give me this value. So instead of this particular, this is the original value. Instead of that, it is going to give me this value. So that is what we are, that particular model, this linear regression. Okay. So the line is linear. So the line what we are drawing is, it's a linear. It is not going to go like, if you draw a straight line, it will go like this. Okay. So this is linear line. It is not going to go like this will. So it is not like any sigmoid or polynomial. So it won't go in that way. So it will be a linear way. So that is what I call it as a linear regression. Okay. So it will try to predict the data points, which will give us the minimum error. So what actually it is a error. So I have a original value 10 rupees. So my model predicted it is at 8 rupees. So what is that? So 2 rupees is an error. Correct? No. So like that, we want to predict the model which will give us the very less error. So if you have more number of errors, so we are not going to use that model. Like instead of 8 rupees, at least it is, instead of 10 rupees, it is predicted as 8 rupees. What if my model predicted it is 2 rupees? So I'm going to get it into heavy loss. So like that. So you can have a question like, why you are getting the error? First of all, why are you getting the error? Why my model is not predicting 10 rupees as 10? So because, so it will take a collective data. So if you look at all the collective data, it needs to find value for all the data. We cannot going to get it for all the each and every individual value. Like if it is 10 and 10, we cannot going to find in the same way. So it will try to find the best fit line to the data, and it will try to get the minimum error. Okay. So which particular set of line will give us the minimum error, that it is going to consider it for the prediction purpose. So so if you look at this, so this is an actual value and this is an estimated predicted value. So if you see in the direct error, so what is the difference? Okay. So that is what it is. 1 second. And next, so 1 second. So what is time? Yeah, we'll just close in 5 minutes. Okay. So here, what will happen is, so you are just plotting the data in the graph and you are trying to find the line. Okay. So we all know how to what is the straight line equation. So the line equation which is which is y equal to mx plus c. So from this we are going to arrive at a model. Okay. So what is a model? So model, we call it as y equal to beta naught plus beta 1 x plus error. So what is beta naught? So beta naught is of your c, the same, because from the line equation, straight line equation, y equal to mx plus c, we are arriving a one linear regression model. So that linear regression model, we are predicting it as a population model. We are trying to represent the same. So like first one is beta naught. Beta naught is of your intercept. The c is called as an intercept, and beta 1 x is like, this is an independent variable and this is an error. So we call it as regression coefficients beta naught and beta 1. So what I was telling, the minimization of error, how are we trying to, how are we going to find the particular best fit line out of many lines? So you can draw a line like this also. You can draw a line like this also. So anywhere you can draw a line. So how I am telling that is a best fit line. So that is the line which will minimize the error and we will give us the best fit combination. So that is what we call it as a best fit line. So to get the best fit line, we will go for a gradient descent. Okay. So gradient descent is the method that will help us to minimize the error. Okay. So this method, what they will do is, so ideally, if you look at very deep, so they will do differentiation and they will try to minimize the error. So if you want to minimize something, we'll go for a differentiation and so they will arrive at this equation. Okay, so they will arrive at what is the value of beta 1 and what is the value of beta naught. So we know y equal to mx plus c. So if you want beta naught, it is like if you want c, so we can just like y minus mx. So that is what it is. So beta naught. So the same beta naught and beta 1. So at the end, we are just going to we are finding the model as y predicted equal to beta naught predicted plus beta 1 predicted into x plus e. So this apostrophe, which is called as a predicted. So that is what we call it. So this is the linear regression model output. Okay, so till today we will just stop this theory part. Okay, so tomorrow what we can see is I will explain so how this, from this equation, how the model is going to get built. So on what basis we are going to find the predictor result and how are we going to find the test data result. So that's what we will continue tomorrow. So up to this is a theory session. Yeah.